And we're live. We're here with, what is this? 5th period, pre-calculus. Chapter 2. Good tomorrow. We're going to be on 2.7.
How many subscribers do you have?
20.
So 20? I never check. I just upload the videos. I don't. Yeah. So, there we go. Alright, let's talk about polynomials. I want you to write this on a flashcard. It's be very helpful. This is going to be, actually, I think you're going to really appreciate having this flashcard, okay? We have, there's some things about polynomials. There's things that are true about polynomials which we need to know. Therefore, if polynomial always does this, then you know if something doesn't do this, it's not a polynomial. Okay? So when we're talking about graphs, okay, so polynomials in terms of their graph, what they look like graphed. Always, number one, are continuous. Meaning no gaps, holes, skips, nothing. It's continuous. Does that make sense to you? The word continuous? It's always continuous. There's never a, jump and start over here. It's never split up into little pieces. It's always continuous. Number two, it's always curved. No edges or points. Okay, it's always curved. Okay. And it's always a function. So it should be able to pass the vertical line test. Alright? It's a polynomial. Let me show you what that means. Visually. Yeah, I'm not. Is everybody done? Can I push it up? I'm just drawing it ahead of time. Shoot, I should have done that in the corner. Sorry. I should have done these different colors. Alright, can I move this up? Alright, here we go. This is an example of a good polynomial, or a polynomial. Okay? It passes the vertical line test. Oh, there's one more thing I need to write down. I'm sorry. I don't know why I have it written down here and I didn't write it up here. 4. The dominion.
What's the dominion?
Sorry, domain. Domain. Dominion is actually a word you use to explain what is the dominion, what is the domain, kind of interchangeable. Alright, domain, let me erase this. Domain equals all real numbers. Okay? Positive infinity, negative infinity. Okay? Domain is all real numbers. So for example, this right here is a good example. It's continuous, doesn't have any gaps. It's curved, no sharp points. It's a function because it can pass the vertical line test. And its domain is negative infinity, positive infinity. As you can see, these arrows point at an angle, so they're going to go forever this way and forever this way. This is an example of not a polynomial, because it has gaps, right? There are holes. So therefore, that is not a polynomial. This is an example of not a polynomial because it has this straight edge right here. It has a sharp curve. Polynomials, if you look at a graph, will never have a sharp curve. If it looks sharp, zoom in. Maybe it's not as sharp as you think. Maybe it's curved. Your graph on your calculator is just zoomed out too far. But if you zoom in and it's straight, then it's not a polynomial. Okay? And then if it doesn't pass the vertical line test, because it hits multiple points, just like any function, it's not a polynomial.
Wait, why isn't the one to the right?
This one? It has gaps.
Oh.
It has holes. No, gaps, holes. If there's an asymptote, then it's not a polynomial. Asymptote. It's a word. Candace, let's be mature. It's a math word, okay?
I know.
I heard you sneeze, but I didn't sneeze. I heard you sneeze. I heard your soul sneeze. I don't know.
Y'all good?
Wait, which one's ours?
You don't need to write these, well, if you want to, you can. They're just examples of that.
That's the only one I need.
This one's good. Yeah, I'll get my green marker. I'll use pink. No, I get blue. This is good. These are all bad. Okay? Okay, that was one flashcard. You didn't need to write the pictures, but if you did for your notes, that's fine as an example, okay?
Let's go.
Who else needs this still?
Nobody.
Becca, come get this. Drawing pictures can be hard sometimes, I know. Okay. That's why I drew them ahead of time. No, I'm just being mean, sorry. Okay. Let's talk about the difference between an even polynomial. So polynomials. Did I spell this right? You could either have an even one, or it could be odd. You playing games? Let me see your calculator.
Uh-oh.
Let me see.
Yep. I don't know how to put games on mine.
Oh, you really? I found the key. What are we talking about for a key?
No, I learned how to plot.
Watch out, he writes his notes in there.
I like that. Let's see, program. No, he's got nothing on there. All right.
Yeah.
He's like, Mr. Hepburn, I'm not smart enough.
That's why you check yours, not mine.
All right. If it's even, okay, the graph, instead of writing a definition, I'm going to draw you a picture, okay? It's going to look like this, or like this. And if it's odd, it's going to look like this, or like this, okay? Huh?
What is odd? Polynomial.
If the polynomial is odd. And how do you determine that? Is that what you're asking? How do you determine if it's even or odd? I'm getting there. Did you write this part? I don't want to overload. Okay. So you know how to define the degree?
Oh, yeah, the exponent. The highest exponential value.
If the degree is even, meaning if your highest exponent for your x term, your highest x, Like if it's x to the 5th power, it'd be odd. If it's x to the 10th power, it'd be even.
Oh, so your x.
So it depends on your, so for example, I'll put it like this, x to the 6th power is even, or x to the 7th power would be odd. So if this is even or odd, that'll determine if your polynomial is even or odd. Now, if it's positive, it'll be upwards or like this, and if it's negative, it'll be downwards or look like this. Okay?
Yo, is that why quadratic is like that?
Huh?
Is that why? No, I'm thinking of a parabola.
You mean quadratics are always parabolas, yeah. That's why quadratics always look like a parabola. Mhm. Exactly. Now, there might be some things in the middle that are different, but it's the tails you're worried about. So remember, we're just talking about, for this, we're talking about the tails. Tails only. Don't worry about what happens in the middle. What happens in the middle, you look at the other card we just made. Okay? Does it pass the vertical line test? Does it have any gaps? Right? Does it, do these, the other card also says that it has to have positive and negative infinity, right? So if these arrows right here are pointing straight up and down, is it a function?
No.
They have to be pointing out a little bit. Right here. These arrows have to be pointing out just a little bit. If it's going straight up and down, it's not a polynomial. Okay? It should be slightly angled, even if it is just barely angled. So there's an asymptote. If there's a vertical line, so that I don't make people continuously laugh, right? If there's limits here, then, which you haven't learned about limits, so I can't say that, then that would not be a polynomial. Okay? I'm going to say this. When you see your homework, so write this down so you don't get confused later, but you don't have to put it on a note card. Don't worry about symmetry. It's going to ask you to tell if something is symmetrical. Don't worry about it. I don't want you to worry about that for now. We learned about that in one of the sections that we skipped over, and I don't want you to have to worry about that for your homework. It's not that important. It doesn't come up a lot.
Does it come up on the test?
If I don't have you do it for homework, you won't have it on the test. Okay. So that's all you need to know to do your homework. Now let's do a couple examples, okay?
Okay.
Now I go to that page that I was on in. I'm going to have to draw all these, but guess what? So are you for your homework. Don't not draw the pictures. Okay? Draw everything.
Gotta show the word.
Yeah, write the problem. Okay, if I have something that looks like this,
What, dude?
okay. What can I say about that? Okay, first of all, it asks me for my domain and range. What's my domain? Let's say this is 0.2. Let's say this is 2 right here, okay? Yeah, it is 2, okay? 0.02 is that line. What's my domain? All my negative, I can go where in this direction? Negative infinity to what? Positive infinity, but x cannot equal 2. Okay? There's multiple ways to write that. For me, that's the easiest way. Or you can do the unification of negative infinity to 2, and then 2 to infinity, not including 2. My range is what? Yep, all real numbers. That double R. Because it goes forever up and forever down, right? See that? There's no space where it can't be up and down for my range. Okay? So that's the easy part that you should already know how to do if you look at a picture. But now I have to ask, is it a polynomial? So it's not polynomial. And why is it not a polynomial?
Yes.
Because gape. It's like gap, but I added an E. Gape. No. Anybody watch Brooklyn Nine-Nine? No. Remember what I'm talking about? Gape. It's like Ukrainian gap.
Oh, yeah.
He's like, it's different than gap. It's called gape. No, it's his birth dad.
Dad?
It's Mikolaj's birth dad. Yeah. Okay. Yeah, you guys got that? So that's how you're going to do it. You're going to get a picture. What is the domain and range? And is it a polynomial? And why is it, or why isn't it? If it is a polynomial, okay, you have to say if it's even or odd. Okay? If it is a polynomial, you have to say if it's even or odd. So read the instructions, okay? So this, you can't say if it's even or odd because it's not a polynomial. But if we connected it right here, if we said there wasn't a gap, what would that be? Even, right? Because they both point up. Although they wouldn't curve out like that. That's weird. They wouldn't, yeah, okay. Now if I look at a polynomial without the graph, can I do the same thing? That's the question. If I have negative x squared plus 3x minus 5, what can I tell about this? What can I say about how it looks? Without graphing it, I can guess what it looks like. What does it look like, you think? It's a 2, so it's even, so the tails are going to both point the same direction, but it's negative, so it's going to be... Alright, we learned about this in the first quarter, remember? Okay. So that's all it wants you to do. Alright. So my answer for this, for like numbers 9 through 13, I would say left tail down, right tail down. Or left and right down. My tails. They're both down. Okay? Left and right are both down. 14 through 17 basically is a repeat of 1 through 8. There's a term there, relative extrema. What does that mean?
It says even.
Relative extrema, what does that mean? It's an even, so you don't have to do it. Like that. Okay. Oh, no. Well, I asked at first, what do you think it means? And then he said, it doesn't matter because you don't have to do it. I'm trying to look at the... Of course it's not in here. Why would it be? Okay. Relative extrema means all the little curves. Okay? Today's Wednesday, is it? So you lunch on Wednesday? If you want to leave early and you don't understand how to do your homework, feel free. If you do want to stay, feel free. 5 seniors. I'm going to keep teaching though, so please be quiet. I'll show you. I have to draw it. If I have a graph that looks like that, my relative extrema are these points, my high and low points of all my curves. Okay? Let me give you a different color. These are my relative extrema. These points right here. They're the high and low, the maximum and minimum.
That's a polynomial, right?
This is a polynomial. These are all my, now where's my zeros at? Can anybody identify my zeros? Just by looking.
Wait, hang on.
Let me label these, brother.
There's a sharp point there. That's
It's a curvy sharp. Let's call it it's supposed to be a curve, but my marker wasn't cooperating. You're right, there is a curve. Good observation. That needs to be curved. I'm trying to tell you what how to so these points right here are my relative extrema. Okay. Okay, meaning those are all my minimum and maximums of all my curves, okay? Then, when I'm going to talk about my zeros, where's my zeros at? Where does my graph cross the x-axis? Right here it touches it.
But it crosses it.
But it crosses it here, so these are my two zeros. So what would this be? This is, let's just call it 1, 2, 3, 4, 5. X equals 2 and 5. Wow, we got it. Or x minus 2, x plus 5. No, sorry, minus 5.
Wait, why isn't the last dot an extreme? Why isn't the last dot an extreme?
Because it's not on a curve. It's not like, see how these are all like parabolas? It's the minimum and maximum.
Okay.
That's right. I get called wrong all the time. Okay? And then my zeros, just by looking at it, are 2 and 5. Okay? That's how you find your zeros. Just look at it and there and there. If it's really close, it's not like exactly, just guess like 3/4 or 2.8. I don't know. Just that's the whole point. This is never supposed to be exact because a graph is never exact. So you're going to have to figure out your own for number 17, okay?
I don't understand.
Check it out.
So I understand the x part.
You understand this?
What is next to the 5 on the bottom?
It's a minus. I messed up. It's x minus 5. So this would be x minus 2 and this would be x minus 5, yeah. Okay. We're not done yet, Rex, so you should sit down. Okay. Okay, we, for 18, 19, 20, I guess you don't have to do that. You just have to plug all those in. You should be able to do that just fine. Alright. Now, if I was going to sketch something, okay, there's a few things I need. So if everybody else left, and they're going to have trouble with this part of their homework, but, you know, optional for...
You have to sketch something?
You have to sketch a parabola.
On what? Oh, homework to do that problem? What the heck?
Okay, let's show this. Y equals x cubed.
329.
Okay, so I need to know a couple things about this before I can graph it, okay? I don't need to graph it perfectly, I just need to sketch it, but I do need to know some things. I need to know how many zeros it has, okay? And so what do I have to do to find my zeros? Synthetic division. What are all my possible factors? Okay. Sorry. Okay, so I either have 1 plus or minus 1 or plus or minus 2. Okay? Because once I divide 1 by 1, I get 1, 2 by 1 is 2. Okay? So, these are my possible zeros, so we're going to do synthetic division. I have to find all my zeros. Let's start with 1. It might work. Let's see. Does 1 work? 1. Let's look in the book so I don't have to waste time. Okay? You guys okay with that?
It
1 does work. Okay? So I do 1. That's going to be 1, negative 3, 2. Bring down the 1. 1 times 1 is 1. Gives me negative 2. Cool. Check that out. So everything is going to lose an x. So that leaves me with x squared minus 2x plus 0.
How'd you know like the 1?
Positive? I looked. He tried it and said it worked. I just skipped ahead because you got to test it. If it didn't work, I have to do negative 1. And so on and so forth. And I just brought out x minus 1, okay? Now I can factor this. What is this? It is going to be 1. Yeah, sorry.
Yeah, x minus 1. X minus 2 is 0.
Wait, I can pull an x out. No, I can't. Oh, wait. Yes, I can. X minus 2. So my zeros are 1, 0, and -2. Because I know, wait a second, no.
It's 1, 2, and 0.
Is it 0?
There should be a 0. Maybe. I just don't know.
Is it a 0? You think it's 0?
This should be +1. Sorry. Because this is 0, it just means that there's nothing left over, but because we're doing division, what happens when you divide out a 1? You're not left with 0.
Yeah.
You're left with 1. So it should be x squared minus 2x plus 1. My mistake. Okay? So this is +1, which, therefore, x minus 2, x minus, wait, x plus,
X squared plus minus 2x.
I'm going to get -2, I need x minus 1.
X minus 1. X minus 1 times x minus 1. Makes no
Oh, yeah,
sense.
positive, it makes
Because I already
it
took out a
towards
+1.
It makes it towards +1 and...
So that should be x cubed then. There should be a -2. There should be an x plus 2 somewhere.
Not really.
That's what the book says is the answer, so I'm...
I don't know.
But I don't know what you mean.
Are you sure this works? 1 works, you could take it out. So that leaves me with x squared minus 3x. Oh! The 2 stays the same. It becomes 2...
What?
Should be 1/2? So here's what it is. If I take this backwards and multiply it in, I should get this. So let's see. X cubed minus 2x squared. Hold on. Plus x. And then I get negative x squared minus 2x plus 1. See, it gives me +1. So this needs to stay at 2. Alright? So that gives me x minus 1. X minus 1 again. No. X. No, I can't factor that at all.
What does the book say?
It doesn't show me the steps.
It doesn't show you the answer.
I had everything else written down except this one problem. Okay, let's just say we found the answer, okay? Really quick, this is the last thing you need to know. I know the answer is x. My x's are, there's 2 1s, so there's 2 of those, and there's a -2. Okay, those are my zeros. Here's how I graph it. Okay, and I'm sketching it. Okay, I know it's an odd, so I know it's going to start at the bottom. Okay, and I know it's going to cross the x-axis twice. Right here. So, oh no, because 1 is the same, it overlaps, and -2. So it's going to look like this. Wait, now it's going to touch that and go up. Sorry. Okay, let me see it right. Yep. Okay. Because it doesn't cross through it, right? Because if it crosses through, then it has to come back across. So this will be my sketch. Alright? So somewhere along here, I messed up on the calculations, but you get that answer, and that's how you graph it. Okay? Have fun. Oh, do you have the same thing? That's exactly the same thing.
I don't want it.
You don't want it, right? I'll take it. I'll take it. But we're open.
Yeah. No, there's a
Oh, it
key
slides
this
down.
side out, and it says closed. Yeah, there's the open.
No? What does it say on the other side?
Open.
It says no. Why is it red then? Open's never red. Come on.
Hey, that's not me, that's why I don't want it.
Manufacturer defect. Alright, you guys are free to go.
That's what I wanted, because it's defective.
Alright. I'm going to work this problem out while I'm sitting out there at lunch to figure out what I did wrong. Okay.
I want somebody to be input.